everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about basic concepts of R programming. So, in this video, I am going to learn about some what are the basic use of R and R programming help. Then, how we are going to give R commands and what kind of data structures are available in R programming, and how we are going to read and writing the data, and some more R commands we are going to discuss in this video. When it comes to the first one, so R project, so R is nothing but a free software environment for statistical computing and graphics, and the bioconductor is the software project for the analysis of genomic data. So currently works as an expansion to R. So R is a free software environment, so mainly used for the statistical computing and then graphics. So we're able to learn more things about www.rproject.org. So the bioconductor is a software project that is going on for the analysis of genomic data. So where we should be currently works for the expansion of R programming. So what kind of packages that are available here in this is, so R consists of core and many packages that are available. So the packages contain the functions that are not available in the core. For example, the bioconductor code is distributed as the several dozens of packages of R. So there may be several software packages and metadata packages. Okay, so the R consists of many core packages, many softwares that are available, and our package may able to contain the functions that are not available in the core. For example, the bioconductor code is distributed as the several dozens of packages of code. So start working with R. So here, once you open this, then we can able to get a tab like this, and from that we can able to click on the directory. So where we can able to extract that demo, and so from that we can able to set this directory. So working directory should be program files. How we are going to set the bin directory in Java and C programming. So in similar fashion we can able to done in this one like bin and okay. So we're going to start working with R main. So here we can able to get some of the display files. So changing the directory. So once we are able to change the directory, then we have to go for the demo folder, and from that we can able to set this working directory of. Suppose if I want to know the help of the start button, then I can how can I able to do that. So just type this help dot start off, so that some separate window is going to be open for the help for seeing any kind of commands or any kind of packages that you would like to know. For that we have to make use of this, and some of the different packages also use and search engines and keyboards, that thing everything you can able to know this. Suppose if I want to know any kind of R programming, so in this, once the help dot top button is going to be used, then you can able to make use of introduction to R. How can able to see that, how are going to install that, and what kind of R language definitions are going to be used, and our installation process, and set up what are the different types of packages that are available, and various search engines and keywords like that we can able to with the help of this start button. So once this help search engine is there, so once we click on this what are the commands and what are the various kinds of thing I would like to know. So if you click on that, so here we can able to get LINE, that should be a simple linear regression example command for that, and cross validation linear regression I am able to get CVLM, and NLS non-linear least square, and then control the iteration inputs like this. Suppose if I want to know what kind of packages that are available in R programming, so here should be the some of the list of packages that are available in this R programming. So if I want to take those annote, so the annotation for microarrays, and base is the under package. You can able to get all base packages, and then boot. So there should be a bootstrap of all functions, and then char there should be of comparison to the linear regression like this. So once we click on in detail about this, uh, then we can able to get some more details about this. And next, what should be the notation for the help of help file here? So this should be indicate the package function packages, and this should be the general description of that package, and the commands and its arguments of it should be what should be the syntax of that, and what kind of arguments I can able to pass in that function. Like this in detail, I can able to find it out here. Okay, suppose if I'm going to open any kind of a package here, so for this package, what should be that? That should be name of the package should be available here. And suppose I want to know some description, then this should be the general description of the package, where some interlinking also be done in detail about the classes what are there in each package, and what should be the syntax, what kind of command and arguments I can able to pass in this. Also I can able to know, and arguments may be object normalized analysis like this happens. So we can detail of arguments that can also be known here, and what the continuation of that, so how the function actually works of in detail of that I can also know, and what kind of values I can also be set it out here, what the function returns and what are the other related functions that are expected to be, and some of the example of that package also be there. So this should be the anatomy of this help file, where you can able to know in detail about the packages or functions that are available in that. So here in detail should be how description would be, that is, where the function is going to be written, what kind of values I can able to store, and where that what kind of function is going to return that, and what kind of the related functions that are available here, and then some of the examples of this can also be, everything should be there in this help file. And next one, what are the functions that are commands in OR? So in order to make use of this function in packages, the packages need to load it into memory, and command for this library should be library of, for example. So there are the three parts in the command, like the command, brackets, and argument passed inside the brackets. Okay, so to use a function in the package, the package needs to be overloaded in memory, and the command for this library is library function. So there are three parts in the command, like command, brackets, and the arguments inside the brackets. And or case sensitive, so here to take care when typing in the command, so the library works, so but the library does not work. So here the multiple commands can be written on the same line. So here we first remove this missing values for the variable, and then we can able to calculate in the arithmetic average, like writing means omit mean, and it should be same as the mean of omit of that, like this. So R should be a case sensitive language. So the typing of the command, suppose if I want to know the library of that, so how can I able to write? So I library of, like, so if I'm going to write like this, so it should not work. So the case sensitive is very important. So Java is also a case sensitive language here, and Python is also case sensitive, where except in the case of the functions here. So the multiple commands have been written on the same line. So here we first remove the missing lines for the variable, and then how to calculate the arithmetic average. So writing like an omit mean, and which the mean of an omit dot here. So the functions are commands in OR. So the command have many arguments, and these are always used inside the brackets. Uh, the numeric one, so or a logic, where you can able to give the value true or false values. And for example, if I'm going to take so the mass of date and then normalize analysis, so like this I can able to use. So the command is going to have many arguments, and these are the thing that should be used inside the brackets. And but the string values such as the file names always put in quotes. And some what are the data structures that are going to be there in our programming. So that should be vector and then factor. So vector is nothing but and then a list of numbers such as list of value that should be enclosed in the parentheses will be considered as a vector. So let how the vector is going to be created in our should be so a and c of 1 2 3 4 5. So it should, c should be the name of the vector that is going to be assigned to an object A here. So these are the list of values. So okay, so this like this we can able to create this vector in programming. So vector like it should be a list of numbers like 1 2 3 4 5 where it should be enclosed in parentheses here. So let's take an example. So example should be so this is the vector c is the vector. So what should be that is there should be the naming of the vector and the values that are passed in the vector should be 1 2 3 4 5. And the data structure what we are going to see in our programming should be factor. So factor is nothing but a list of values that should be either numeric or string. And so so here also how can the factor should be created. So using a factor function of a as dot should be the object that should be assigned to the object b, where the vector is going to be converted into a factor here. Okay, so this is the vector initially what it adds, right? So further what I'm going to do, I'm going to convert the vector into factor. So how to done, so it should be as dot variable dot then factor of that vector name which should be assigned to object. So the factor should be either numeric constant and should be going to be conductor and should also be list of values here. And data structures should be a data frame, which should be nothing but a table where the columns can be numeric and string values. And so how this one is going to be created, so by make use of the command like data dot frame of a comma b that should be assigned to the object. So everything what is there you can create it here in our programming that should be compulsory assigned with the object here. Okay, so the data frame, it is nothing but a table where the rows and columns can be numeric and string values. And so how this can be created, so data dot frame of a comma b that should be assigned to the object. And matrix, so matrix is nothing but all column must be either numeric or string values, but this cannot be combined. And so how can I able to create, so as dot matrix of d, so where the data frame is going to be converted into matrix. So this is the right. And another thing what I'm going to be considered, so where this thing again the matrix is also further converted into data frame as well. So the matrix is again going to be converted into data frame. So like this, the vice versa also be done here in our programming. Okay, so all the columns must be either numeric or that should not be combined. So as dot matrix of D, and so where the data frame is going to be converted into matrix. If I'm going to same thing, I can able to pass as this framework. Again the thing should be converted into the data frame. And next one should be a list. So list is nothing but a list of objects of different types. So how can I able to do that? So same thing, I can able to take an object as does list of D, where I can able to convert the data frame into a list G. And class structures. So maybe many of the biconductor functions are going to create a normal structure, and they should also be contain a data in the form of slots, and these slots can be accessed through at the rate of operator. So this should be this at the rate of operator, where can able to access the file names through at the rate of operator here. And some commands need to get here, for example a matrix that do not accept the data frame. So at the time what the data frame would get an error message. So in order to check that, so we have to know the what type of object it is. So for that we have to specify class of D. So once you specify the class of D, whether it should be a integer or it may be a string object, I can able to know that. Okay, so to check whether what fields that there in the object should be, uh, here suppose D I can able to specify, so string of D, so I can able to convert that into the form of a string here. And then to check the size of the table, so kind of dim is a function here to know the dimensions of the table, and to know the length of the vector I can able to make use of length here. So these are the some of the data structures that may be get here in order to know, so the class of that, and then what kind of string it is, and dimensions and length. So these are some other uh, functions that are going to be there in that data frame. And some other data frame also related to commands was there. So like names of the should able to report the column names, and if I want to know row dot names, I can able to report the row names here. So this should be something different. So if you specify only the names, then it should be comes under column names. And suppose if I'm going to specify the only row dot names, then you can able to specify only the row names. And this can be used for giving the names for the data frame, and row dot names they should be there. So where the letters from A to B should be as well as row names for the data frame. Note that there should not be any quotes around the string values. And if I'm going to specify the row dot names of D, then I can able to get the row names as well. And next one should be naming objects. So here naming objects should be never use the column names as the row object names. And if we are going to ensure whether something in command name type to the common line, then it gives them some error message. So that means you are safe to use it. And object names cannot be start with a number, and never use special characters such as a and object names, and underscore is not usable, use dot instead, and not acceptable should be good underscore data, but it should be good dot data. And the object names are should be case sensitive, just like commands here. So the naming objects should be never use the commands as object names. And if you are going to ensure that something is there in command name, then if you are going to get an error message, then how can you able to save to use it? So for that, what you have to do, the object names should not be started with the number, and never use the special characteristics like this in object names, and underscore is not at all usable. So instead of that, it is better to use dot instead. So like good underscore data is not acceptable one, so the better way should be good dot data. And object names are case sensitive, just like the comments here. Then next one we're going to see how we're going to read and writing the data here. So the command for reading the data in text file is that read dot table, and so me dot text header equal to t, and September /t. So this should be examples of one of the command with the arguments. So file names in quotes, header that tells whether the column have titles, September that tells have file in the table delimited. Okay, so the command for the reading text file should be that. So this means once the example have command with the arguments, so file names in quotes, header that tells whether the columns have titles like this, and September for the table tab delimited. So reading data to what is another way. So it is customary to save the data in the form of object in R. So normally this should be done through assignment operator. And so here the data that is going to be read from somi.txt is going to be saved in the form of object in our memory, and the name of the object on the left, and what is assigned to object on right. Okay, so normally you have to make use of command id dot table of creates the data. So it is compulsory, right? It is customary to save the data in object in all, and this can be done with the assignment operator. And here the data from the file going to be stored in memory here, and name of the object always should be lines to the left side, and what is going to be assigned should be available on the right side. So the command read dot table of will be able to create the data frame. And next one, using of data frames. So in thus individual columns in the data frame can be accessed using one of the following ways. So use its name like data dollar year. So date is the data frame, and year should be the one of the columns header, and dollar is the operator that accesses the column. Okay, and split the data frames into variables. So use the names directly like attach and then here, and make use of scripts as well. So individual columns in the data frame can be accessed through one of the ways. So either through the name, like date is data frame name, dollar, and year. Year should be one of the column header. How can able to access that? To make use of this dollar operator. And next one, we have to split the data frame into variables like attach and then year, and also sometimes you can also make use of the subscripts. So what should be a subscript actually? So subscripts are the uh, given inside the square brackets of the object name, like uh, date, data frame, comma of column 0, 1. So I'm just specifying only one. So that means that I can able to get the first column of the object data. And if I want to know the object first row of the data as well. And if I want to know the first row and first column of the data, then it should be like this. It should be normally like this. In this fashion, it should be 0 here. Okay, the subscripts uh, here should be accessed in the form of subscripts what the data of that any data frame. So if I'm going to specify 0 1, then it should be uh, abstracting the first column of the object. If I'm going to get 1 0, it should be the first row of the object, and the data should be can able to extract the first row and first column of the object. So now the data is now object that should not a command. Sometimes the subscripts can also be used for extracting a subset of data, so date of which dollar. Now, this takes a bit of pondering to work out. First, we have object data, and we're going to accessing the part of it because it is named by following the square brackets. And then we have one command which make evaluation whether the column in the object date has a value higher than 1900. So then law subscripts ends with a comma. So that tells what we are accessing rows. And note this command takes all the rows that have a year higher 1900 from the object data that is the object data frame. Okay. So that means that so the subsets are normally is going to be used for extracting the subset of the data. Okay. So this is the data frame. So normally the data should be like a table. So if I want to access some particular part of this, then I can able to go for the subscripts here. So for that I can able to write a query this for date dot year where it should be 1990 greater than 1900. So first what have to have an data object for accessing the part of it because it is going to follow the square brackets. And then we have one command that makes evaluation whether the column here in the object have a value, and this command also make the rows that have higher that. And then next one, writing tables. To in order to write the tables, so we're going to have write dot table of this date frame and date dot text. We're going to extracting and then separate. So here the object should be written to a file called date.txt, and this file should be a tab delimited. And in order to capture this what written on screen, so sync output.text that sync of function something like this is going to be using this. So the sync of means where the output written on the screen should be written to the file output, and then the contents of objects are going to be drawn to named file. So if you are going to accidentally omit the last command, so you will not able to see that any output screen, because output is still redirected to your file. So writing table, so we're going to have a write command, write dot table, and what should be the data frame, and we're going to be able to write it like data.txt and what kind of separator I'm going to use here. So here the object is going to be returned to a data file, and this file can be tab delimited. In order to capture what is written on the screen, like sync.output.txt, date, sync of the functions. So once where the output are going to be returned to the file output instead. And then contents of the object drawn to the name file. Finally, how to close the file. And if I'm going to accidentally omit the last command, so we will not able to see any output on the screen. So because so the output is still redirected to the file output. So quitting or how we're going to do that. So we're going to have the command called q or function or menu choice should be file exit. So the or is going to be asked whether we are going to save the workspace image. So if you do that, so all the objects currently all memory are going to be saved to the file, and the command will be returned to the file history. So this can be loaded later, but we can able to continue work from that. We have to left it out. And loading can be done after the starting view or using menu choices. So like file load workspace or like file load history. So these are the some of the options we are going to have for that. So for quitting, we are going to do and have free of the function, or simply you can able to write go to file menu and then click on this exit. So now when I'm going to ask a quick command, so the ask R is going to ask some whether we have to save the space or not. So for that, so it is going to ask. So once you click on this, then it should be automatically written into file.data, and all the commands what is written should be written into the file history. So the loading can be done only after the starting using or menu the choice should be there, and file should be load file workspace and load history. In summary, so the commands can be recognized from brackets, so that follow them, and if you are going to calculate how many bracket space there are, you will be able to identify the number of commands for that. So p data and assignment to be object denoted by, so like this, or I can able to use, or I can able to use. So the table like objects is going to be followed by square brackets, and square never be associated with the commands, only the objects. And special characters like dollar and at the rate is going to be used to define individual columns in the data frame or individual slot of the class type of an object respectively, like data dollar here and data at the rate name. So the commands can be recognized from the brackets, so that should be follow them. And if you are going to calculate, so then you should be identify that. So assignment should be an object that should be denoted by, and if you see the notation, then you will be looking for comparison operator, and the table like objects often followed by square brackets, and square never be associated with the commands, and special characters can also be used. Well, comes to installation of R. So first go to the site of project for statistical computing. If you are going to see the left side, so cpan, so downloading that, so we're going to be able to download our software, and so you can able to use, so based on the country I can able to download it. So it may be opposite of that Austria and Australia, China like this. So there may be several member files are available here. So for what kind of operating system you want to download, you can able to choose it. So it will be Linux or it may be Mac or it may be a Windows 95 like that. So like this we're going to separate so many files. And so if I'm going to use for Windows, then we have the base version of that one. You can able to do that in order to support that all the files and directories. So once you click on that Windows, again we're going to have what should be the package that are available and what are the new features that are added here and use all versions of an able to extract and select this R2.3.0 Win32 package. So download it and we can able to run that file so that you can able to run that file easily and you can able to install the R editor. So already I covered some of the videos in R editor, how to use that and how can able to what are the different quadrants of R editor, where should be workspace where can able to get the output and where should be that everything I can able to know. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.